Cogito ergo sum. I think, therefore I am. Rene Descartes, sometime in the Renaissance. Boys and girls, welcome to video lesson 2-1, chapter 2, section 1, geometry. Our lesson on inductive and deductive reasoning. Okay, what is inductive reasoning? Inductive reasoning is reasoning based upon what we see, based upon observation. It's what we think to be true based upon our perceptions. A conjecture is a guess. It's a guess upon what we think to be true based upon inductive reasoning. So a conjecture is a guess. A counter example is an example that proves something is false. It proves a conjecture is not true. For example, I can go outside and look around, and I see a lot of birds flying. They're flying through the sky, geese and starlings and all sorts of things. So I can make a conjecture that I'm going to say all birds fly. That's based upon my observations of seeing all those flying birds. However, a counter example to the conjecture is all birds fly would be a chicken. Chickens don't fly. Chickens walk around on the ground. Bok, bok. Okay, so the other type of reasoning is deductive reasoning. So inductive reasoning, what we just talked about, is reasoning or facts based upon observations. It may or may not be true. Facts that we conclude by deductive reasoning is definitely true because deductive reasoning is reasoning based upon definitive facts, laws, or proofs. For example, it is illegal to drive 85 miles per hour in the Simsbury High School driveway because there are posted signs that say you're supposed to drive only 15 miles per hour. So it would be deductive reasoning to conclude that it is illegal to drive 85 miles per hour in the Simsbury High School driveway. Okay, you guys try these two these sequences here. Write a conjecture based upon the following. In other words, I want you to write for me what's going to be the next term you see right here. So you have A, B, B, C, 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 D, 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 D. What do you think comes next? Do the same thing here. 5, 12, 19, 26. What comes next? And write me a sentence that would explain why you think that reasoning would be logical. Okay, I'm hoping you wrote 5 lowercase e's for this one right here. And again, based upon observation, inductive reasoning, we would think if I have a single lowercase a and 2 uppercase b's and then 3 lowercase c's, 4 uppercase d's, it would make sense based upon this observation that the next term in the sequence would be 5 lowercase e's. Again, this is inductive reasoning because there is no rule that says that this would or should be next. Maybe you wrote 33. Maybe you wrote 33 here because, again, inductive reasoning might say 5 plus 7 is 12, plus 7 is 19, plus 7 is 26. Inductive reasoning might make us conclude that the next one is going to be 26 plus 7, which is 33. But maybe these are Saturdays in the month of April. So we have April 5th. April 12th is the next Saturday. April 19th would be the next Saturday. April 26th is the next Saturday, but maybe now the next one would be May 3rd, so maybe the next sequence here should have been 3 and not 33. And there's where we have the fallibility, or the fact that inductive reasoning is not always perfectly true. Okay, spend a couple of seconds here, write down what you think about a conjecture. When I say the sum of 2 odd numbers is blank, what do you think that is based upon some inductive reasoning? Okay, I'm hoping you're writing here that the sum of 2 odd numbers is always going to be an even number because 3 plus 5 is equal to 8. 8 is even. 5 plus 11 Those are two odd numbers. 5 plus 11 is 16, which is even. 7 is an odd number. Negative 3 is an odd number. 7 plus negative 3 is positive 4. These are all even numbers, so inductively we can conclude that the sum of two odd numbers is even. Again, we can prove this algebraically, but that would be deductive reasoning. That would be deductive reasoning. Okay, and this guy right here, we want to write a conjecture based upon the following. What's the relationship between segment AB and the set of all points that is equidistant to points A and B? So let me just draw a point, any point that is equidistant to A and B. I could draw actually the midpoint of A and B, so those two things are equal. I can also draw another point. I'll do that in a different color. I'll do it in red. I could draw a point right here, where this point right here, this red point, is the same distance away from both A and B. So these two segments are equal. I can do another point in green. We'll do it right here, where this segment drawn to A is congruent to this segment drawn to B. So those two are equal. We'll do one more in yellow. If I draw a point down here that's equidistant to both A and B, so this distance to B is equal to this distance to A. Now, what can we conclude about all these points? Any point that are equidistant to A and B, well, all these points would lie on this line right here. Well, this line is going to be the perpendicular bisector of AB. And again, this is inductive reasoning. It's just what appears to seem to be true, but we haven't proven that, and we will do that later this year. Okay, we're going to do these three little problems right here. Determine whether each conjecture is true or false. If they are false, give a counter example for any false conjecture. So stop the tape and go ahead and give it a go. Okay, you should have found that the first one is false. For example, if x is an integer, then negative x is positive. The easiest one to do would be, what if x were 3? If x is 3, then negative x would be negative 3, and that's not positive. So this inductive reasoning right here is false. It's not true. Number 42 is also false. We're going to draw a picture. Let me switch colors. I'll do this one in red. If angle 2 and 3 are supplementary angles, then 2 and 3 form a linear pair. Well, it's certainly possible that I have angle 2 and angle 3. They form a linear pair. But it's certainly possible that angle 2 is right here and angle 3 is right here. They add up to 180, but they are not linear pairs. And certainly on number 43, if you have 3 points, A, B, and C, then A, B, and C are non-collinear. Certainly I can have A here, B here, and C down here, and that would work where A, B, and C are non-collinear. But what if cross B out here and put B right here on the same line as A, B, and C? And now, of course, if you know, we're going to connect those points on a line, and now A, B, and C are collinear, so therefore there is a counter example to numero 43. Boys and girls, that's all she wrote. Short and sweet today. We shall see you soon. Have a great day. Adios.